All right, similar to what you had in Calculus 2, probably. If you've got an area to integrate that gives you problems, like you get a couple different functions meeting up, you need to break it into pieces, there's a way to do it here. So if you've got some sort of region D that is equivalent to the union of two pieces, essentially, if you can add those two pieces together where they don't overlap except at the boundaries, then when you take the integral of the whole thing, it's equal to the individual pieces integrated. And again, you should have seen something like this in Calculus 2. All right, so let's do this number 97 here. Let's draw a little graph. All right, so we've got two functions here. We're going from x minus 1, so y equals x minus 1, and the other function goes 1 minus x, so y equals 1 minus x. Now note we're going from 0 to 1 on the x values, so really the area of interest is what's in this here. And I'm a little out of the lines, but hopefully you get the idea. So again, easy if we're doing it, if we're evaluating the dy's first. As we go from the bottom one to up, and there's no problem after that. Now, if we have to go left to right first, we have to switch these around, which is what the question wants us to do. We're really running into a problem where we've got two different functions. So it's going to break this into a d1 and a d2. So we can go as far as this, we can go to this and then to this. All right, so with d1, we're going from, we've got y equals 1 minus x, which means that x equals 1 minus y. So that's what we're looking at for that. And for d2, we've got y equals 1 minus x, so that gives us x equals excuse me, y equals x minus 1 for that one. Which gives us then x equals y plus 1. Okay, so we've got a situation where, although my graph doesn't look like it, we have some symmetry that's going around the x-axis. So each of these regions is going to be the same area. So we'll use the top one. So this is going to equal, we're going to go from it's going to look like that. We're just going to do D1, but there'll be 2 times that. Okay. And then we've got an x, and we're going to go with dx dy. Again, pick either one, it doesn't matter, but we're going to use the top one. Let's see. It's going to be 2. The integral of x is x squared over 2. Evaluate from that 0 to 1 minus y. 1 minus y quantity squared over 2, which we can do here. We can let u equal 1 minus y, which makes du equal to negative dy. So here we're going to have negative 2, and then this is going to be 1 minus y cubed. Actually, we'll pull out the 2 as well. This is going to be over 3, and that's evaluated from 0 to 1. All right, so this equals negative 1, and I'll put in 1. That gives us 1 minus 1 cubed over 3, which is going to go to 0. And we're minusing 1 minus 0 cubed over 3. Okay, so that equals just 1/3.